Welcome to The Explainer. Today we're diving into a foundational concept in software engineering that completely changes how we think about quality and reliability. Whenever a team sets out to build a new piece of software, they rely on a framework known as the Software Development Lifecycle, or SDLC. This cycle is basically the blueprint for taking an idea from a blank whiteboard all the way to a fully deployed application. But when the stakes are incredibly high, you can't just wing it. You need a highly disciplined SDLC to deliver projects that are robust, secure, and above all else, reliable. Okay, let's dive into this. How exactly do developers prevent catastrophic bugs in critical systems right from day one? I mean, if you're building software for a hospital ventilator or a global banking network, you simply cannot afford a system crash. The answer actually lies in a development model that anticipates failure. It builds in rigorous checks at every conceivable step of the journey, making absolutely sure that defects are hunted down long before the product ever reaches the user.
So here's our roadmap for today. First, we'll meet the V model. Then we'll cover verification, which is the left side, followed by validation, the right side. After that, we'll anchor all of this with a real-world ATM example. And finally, we'll weigh the pros, cons, and comparisons. Let's get started.
Section 1. Meet the V model. To truly appreciate what makes this framework so powerful, we really need to look at its origins and how it completely reshaped traditional software development. The V model is essentially a highly disciplined extension of the older traditional waterfall model, but it introduces a brilliant twist. Instead of leaving all the testing until the very end of the project, which, let's be honest, is a recipe for disaster, the V model mandates that every single development phase has a corresponding testing phase planned right alongside it. I want you to think of this like a giant mirror. For every step you take to design the software on the left side of the V, there's an exact mirror image on the right side dedicated to testing that specific design.
Now, what's really interesting about this is the precise distinction between verification and validation, which are the two main pillars of this model. Verification on the left side asks, are we building the product correctly? It's entirely process-oriented. It happens completely through reviews of documents and designs before a single line of code is ever written. Validation, on the right side, asks, are we building the correct product? This is product-oriented. It requires actual execution of the software to ensure it behaves exactly as the customer requested. Basically, one is checking the blueprint, the other is checking the building itself.
Section 2. Verification, the left side.
All right, we're going to start our spatial descent down the left side of the V, where our entire focus is on verifying requirements and designs on paper. Imagine you're walking down a staircase. At the very top, step 1, we have requirement analysis. This is where we gather broad customer expectations and document the project scope into a software requirement specification, or SRS. Stepping down to step 2, we hit system design. Here we outline the overall architecture. We're selecting the hardware, network, and database structures. Moving down to 3, high-level design, we start breaking the software into specific modules and define how they're going to interact through APIs. And finally, it's step 4, low-level design. We get extremely granular. We're defining the internal logic, variables, and algorithms of those specific modules. So we've literally gone from broad ideas down to microscopic details.
And now we hit the very bottom of the V, the coding phase. This is the ultimate pivot point. Armed with incredibly detailed low-level designs, the developers finally implement the modules and write the actual source code. This marks the exact moment where our theoretical development ends and our practical testing ascent begins.
Section 3. Validation, the right side. Get ready to climb back up the right side of the V, where we test the living, breathing software against the exact plans we made on our way down. Let's move to plots and see how this builds from the ground up. We start the climb with unit testing, verifying individual modules in total isolation, like, say, checking just a single login function for programming errors. Moving up, we perform integration testing. Here we check the data flow between modules, making absolutely sure Module A correctly talks to Module B. Continuing upward, we reach system testing, which validates the entire integrated software for performance and security. And finally, at the very top, we conduct acceptance testing. This is where the customer steps in to approve the software, verifying it actually meets their original business needs.
Section 4. The ATM real-world example. It's always best to transform a theoretical framework like this into a practical industry application so you can see exactly how it functions out in the wild. Imagine you're hired to build software for a brand new ATM. You start at the top left by gathering requirements. What functions does the bank actually need? Cash withdrawal, balance inquiry, PIN changes. Then you travel down to design the screens and the secure database architecture. At the bottom, your team writes the code. And then you start traveling back up through your tests. You unit test the cash dispenser module, you run integration tests to ensure that when the dispenser gives out money, it properly talks to the account balance module to actually deduct the funds. Finally, the bank executives perform acceptance testing before they ever put that ATM out on a city street.
Section 5. Pros, cons, and comparisons. So, no software engineering model is perfect for every single scenario, which means we need to analyze where this framework shines and where it falls short. And this brilliantly illustrates the night and day difference between the older waterfall method and the V model. In waterfall, testing happens entirely after coding, meaning you find defects late. That makes the cost of fixing bugs incredibly high. But look at the V model. Because you're planning your acceptance and system tests early, while you're still just designing the software, you detect defects early. This significantly reduces the cost of fixing bugs and elevates the overall quality of the final product from moderate to high.
Now, if you're taking notes for an exam, these are the key advantages you absolutely must memorize. The V model guarantees early defect detection. It provides highly structured milestones, which translates directly to simple, predictable project management. And because testing strategies are literally woven into the very fabric of the design phases, the ultimate output is exceptionally high-quality software. The early planning simply eliminates the surprises.
But, of course, we have to contrast those strengths with the model's major weaknesses. The V model is extremely rigid. Once you travel down the V, going back up to change a core requirement is incredibly expensive and difficult. Furthermore, there's no working software to look at until very late in the cycle. Because of this lack of flexibility, the V model is a terrible fit for fast-paced agile projects where customer requirements are constantly shifting and evolving from week to week. So, the crucial point is this: context matters. When you're building systems with stable requirements where accuracy is quite literally life or death, like banking systems, medical ventilator software, aviation flight controls, or military applications, this rigorous, uncompromising framework is the undisputed choice. In these specific domains, you want the rigidity, you want the exhaustive verification and validation.
As we wrap up today's explainer, I want to leave you with this thought. The next time you step onto a commercial airplane or use an ATM or visit a hospital, think about the code keeping everything running behind the scenes. Knowing what you know now about the rigorous testing of the V model versus the fast-paced shifting of Agile, which SDLC model would you trust with your own safety? It really puts the stakes of software engineering into perspective, doesn't it? Keep exploring, keep questioning, and I'll see you in the next one.